I'm very happy to be here, to be invited back. I decided to think about a talk that would have something to do with Victorian times, since I knew what my sister was putting together for her musical program. So I thought I would give you a story that I've sort of been intriguing me a little bit over the last year or two. That is basically the connection between what was going on in astronomy in the 19th century and what was going on in popular culture, science fiction, and so forth. So that's what the topic of the talk is tonight. So here's a little outline. So first of all, I'll talk about a little bit about what was going on before 1800. And then that's the astronomy part in the 19th century, and then I'll talk about the very interesting story that relates to Lick Observatory to some extent, about the canals on Mars, and then talk about science fiction and popular imagination. Now, if you look at the web page for this series of talks, it suggests that you're going to hear something about current research, which I didn't know until I looked at the web page a couple of days ago. But at the very end, I'll be able to tie this in to current research here at Lick Observatory. So we'll get there. Okay? So let's start with Nicolaus Copernicus. So here he is, being astonished by what he's discovered. But this is not a very clear... you can't see it very clearly, but the diagram here shows his model for the universe, which is the sun is at the center of the universe, and the planets go around the sun, which was a completely revolutionary way of thinking about things. Prior to Copernicus, the notion was that here we are on the Earth. The sun rises in the east, sets in the west. The moon rises in the east, sets in the west, and so forth. So the Earth is motionless. We see the stars and everything rotating around the Earth. The planets are dots in the sky that wander around amongst the constellations, and various notions are put forward to understand all of this. But the Copernican idea of having the sun be the center of the universe and the Earth being one of many planets that orbit the sun simplified everything. It was a much, much more sort of economical way of thinking about the universe. And it had some consequences, of course. The consequences that now the Earth is one of those dots that's wandering around among the constellations. So to the extent that here we have an Earth that we're standing on, and the dots that are wandering around in the sky are like this thing that we are standing on, then it must be that those planets must be like the Earth. So there are other Earths in that sense out there. So that was sort of the way the logic went. And if you take this logic another step forward, and a Dominican friar named Giordano Bruno was an adherent of the Copernican picture, and he took it several steps further. Now this is really just speculation, because at this time there was no real measurements that would be able to demonstrate that these notions were correct. But his rather insightful notion was that the sun is a star, like all the other stars, and so the stars are simply fainter because they're much, much farther away. In fact, he had this notion of the universe being infinite. And then, of course, if there are other stars that are like the sun, and the sun has planets, according to Copernicus, then these other stars must have planets as well. And if you have an infinite universe, you have an infinite number of opportunities to populate planets with anything you like, in particular inhabitants of various flavors, some of whom could be intelligent. So this was a rather disturbing notion at the time for the Catholic Church, because you have to think about, are these other beings, do they have souls? And if they have souls, do they need to be redeemed? And so on. The Church was not prepared, was not able to think about how you'd accommodate that within the boundaries of current practice. So Bruno met an unfortunate demise. He spent a number of years wandering around Europe. He visited London, he visited Paris, he spent quite a few years as kind of a wandering philosopher, you might call him. I think by this point he'd been kicked out of the Dominican order, and he came back rather ill-advisedly to Italy when he was arrested by the Inquisition, and he was executed for heretical ideas on this site here. So this is a piazza in Rome called the Campo dei Fiori, and the statue that you can see just a little bit to the left is a memorial to him. So he was ahead of his time, unfortunately. And then we come to Galileo, a very celebrated person who was really, in my mind, kind of the first scientist in the sense that we would recognize today. He basically rejected the notion that you could derive nature by philosophy, that his approach was empirical, that you made measurements of things and you made deductions based on those measurements. So he is, of course, famous for using the telescope to make all kinds of wonderful discoveries. For example, the phases of Venus essentially clinched the Copernican picture for how things had to move in space. Another thing that he did was to make very systematic observations of the moon, which is a very important part of this story. So here on the lower left is one of the chapel pictures of the moon. And on the upper left is one of Galileo's drawings of the moon. And essentially what he saw, and now today we just take this for granted, but at the time it was really revolutionary, that he saw mountains, he saw valleys, he saw plains, he saw things casting shadows. He was able to, in fact, derive the heights of the mountains from the lengths of the shadows. In other words, what he saw was an Earth-like body. So prior to the telescope and Galileo's very adroit handling of the telescope, no one knew this. No one knew that the moon was like the Earth. And all of a sudden, here is an Earth-like object, something with mountains and plains and valleys and so forth. And so this started to get people thinking, right? So there are worlds out there. And as this note says, that we now move from speculation really to observation. So after the beginning of the 17th century, things really started to change. So there was a number of philosophers and theologians who started to think in a different way. So here is this is actually a photograph, an amateur photograph of Jupiter and the 4 Galilean satellites, where Kepler, for example, was one of the people who said, well, how is it that we have these things which were only recently discovered by Galileo, right? Why would God do that, right? Why would he create this thing and wait for Galileo to happen to point a telescope at it? So there must be beings on Jupiter that would appreciate these moons in the same way that there are beings on the Earth that appreciate the Earth's moon. So it was a very different way of looking at things, right? So instead of having an infinite, instead of rejecting the idea of an infinite universe, you embrace the idea of an infinite universe with multiple opportunities for beings on other planets. Okay. So in the 19th century, let's see, this is just a reminder of where I am in my outline. So I'm just going to go through a little catalog just to remind you of what things happened in the 19th century from the point of view of astronomy. So one of the things that was of crucial importance was that up until about 1820, there was a notion that the stars were like the sun, and by taking the ratio of brightnesses, you can guess how far away the stars were, but no one actually knew how far away the stars were, because we had not yet succeeded in measuring what we call a parallax, which is a surveyor's technique for measuring large distances. But in the hands of an extremely adroit German astronomer named Friedrich Bessel, finally, and some others, Struve and some others, started to measure the distances to some nearby stars. And that was around 1820. So all of a sudden, things started to lock into place in terms of getting a picture for outside the solar system, the universe outside the solar system.
How did they do that?
That was done by measuring it was essentially triangulation. It was measuring the position of, let's say, 61 Cygni with respect to stars in the neighborhood of in the angular neighborhood of 61 Cygni. When the Earth is on one side of the sun, and then 6 months later when the Earth is on the other side of the sun, and since you know the size of the Earth's orbit by this time, then you can calculate the distance to the star. And so that was a huge achievement, and it's a very, very difficult measurement because the angle is absolutely tiny. The next thing on my list here is that the term spectroscopy refers to breaking up the light of a star using a prism and to see a rainbow. But when you do that, you don't just see just a simple rainbow. You see a highly structured thing that is very diagnostic. It turns out you can tell the chemical composition by the features in the rainbow. You can tell the temperature of a body. You can tell how fast it's moving towards you or away from you. And so the technique of spectroscopy came into its own in the 19th century. And then down at the bottom, this is really fitting together the emerging ideas from physics. There's sort of basic ideas about Maxwell, of course, was in the 19th century. Max Planck was in the 19th century. His notions about thermal radiation, all this kind of stuff, it all started to come together. And the understanding of the real understanding of stars was really something that happened in the 20th century in terms of their structure and their evolution. But the pieces were being put in place in the 19th century. This is just an account of some of the solar system what was going on with solar system investigations. So asteroids, the existence of asteroids wasn't even hinted at prior to the 19th century, and all of a sudden they started to be discovered, about one a year. It was by the end of the century there were 400 asteroids discovered. So a whole new phenomenon was discovered. Neptune was discovered which is a brilliant validation of Newtonian mechanics. It was because of actually not just happenstance, of chance of just randomly finding a new planet, but it was by calculation of the very tiny changes or what we call perturbations to the orbit of Uranus, that it was deduced that there had to be another planet out there. And that was in 1846. And so it was predicted to be at this place, and it was there. It was found just where it was supposed to be. The precession of Mercury is a small effect, and what is precession of Mercury? So Mercury has an elliptical orbit, and with time the long axis of the ellipse gradually moves around, and so it precesses or moves around in space. Was a puzzle for Newtonian mechanics. So just as the discovery of Neptune was a triumph of Newton's theory of gravity, this precession of Mercury business, one of the things that inspired Albert Einstein later to say, okay, we have to move beyond Newton's theory of gravity. We need a new theory of gravity. And so that not the explanation, but the data was something that was part of the 19th century. And then discovery of the moons of Mars and many other moons of many other planets. So I just give that as an example. And then just a quick review of some technological advances. So telescopes were much better at the end of the century than at the beginning of the century. And one of the people who is very much responsible for this development was the same person who brought you the pendulum, Foucault's pendulum. So he was a physicist working in France and made many contributions to the and also Josef Fraunhofer, who is famous for building spectrographs and using spectrographs, was also an optician and another person who made important contributions to refining telescopes. And then photography was invention really started to be used in astronomy. I would say around 1880. And that, of course, changed everything, right? You can imagine that if you don't have something to record your observations, if you're just your eyeball against an eyepiece, it's a very different story than if you can actually record it quantitatively. Okay, so what were people thinking about doing in the 19th century? So what were people motivated? Why were they building new telescopes and things? Well, here's a list. One of the things you can do is make even more precise measurements of positions of stars, which allows you to measure their distances by the same triangulation technique. Once you've got their distances, you can measure a very tiny motion across the sky, which tells you how fast the space motions of stars in space, in three-dimensional space. You can measure two stars moving around each other, which allows you to measure their masses, which is an important, we would say the most important property of a star is its mass now. And then instead of just collecting spectra and seeing that there are these different patterns there, you actually start to apply physics to unraveling the meaning of these patterns in spectra for both stars and the glowing clouds of gas. And then more and more effort was put on not just observing planets and the moon and the sun, but also just refining the measurements by developing techniques for more precise, being able to see finer detail, essentially. Okay, so here are a few examples of what some of the astronomers at the time were thinking in terms of life elsewhere, to come back to that theme. So William Herschel is one of the greatest astronomers who's ever lived. I think that's a very defensible statement. He was originally a musician and went to the United Kingdom and made his first major discovery was the discovery of the planet Uranus, which granted him, which sort of propelled him from being an amateur astronomer to the kind of a court astronomer. He had the financial resources to build large telescopes. He discovered infrared radiation, and then he started making maps of the sky, sort of surveying the sky. He wanted to build up a map of the distribution of stars in space. So he was really thinking about building up the big picture. This is absolutely what professional astronomers are doing now. And it really started with him. So if you wanted to think about a CV, discovering a planet, discovering infrared radiation, and conducting surveys of the universe is not a bad thing to have on your CV. So he did many other things, of course. But now this quotation I have here, you see that its inhabitants probably enjoy a situation in many respects similar to our own. It's clear that he's just assuming that, of course, Mars has inhabitants. It was completely natural to him to assume that. He assumed that there was life all over the place. It wasn't just Mars. I'm not saying that every astronomer thought this way, but it was not an uncommon thing for him to think that. For him, here's another astronomer. This is one of the preeminent Jesuit astronomers of the 19th century. He was an expert at classifying stellar spectra. In fact, the current system of the sun has a certain type of spectrum. Remember, a spectrum is a rainbow, and we're talking about the features in the rainbow. They're hotter stars. He did all kinds of other things. He worked in other natural sciences. There's a gadget called a Secchi disc that's used to measure how transparent water is. For example, you might want to measure the amount of particulate matter in a lake or a river or something like this, and you drop this disc into the water and you measure how deep it gets before you can't read the markings. And he invented that. Anyway, a very well-rounded person. Then yet another person is this fellow here, Flammarion. He was 16 years old when he was hired as an assistant at the Observatory of Paris. And as you can see from the dates here, when he was about 20, he published a book called La Plurality des Mondes Habités, okay, which is the title of my talk, The Plurality of Inhabited Worlds. And this was a little bit over the top, even by the standards of the time. And he was summoned by the director of the Observatory, who is Leverrier. And Leverrier was the fellow who discovered Neptune, who predicted where Neptune would be. And Leverrier also made the measurement about the precession of Mercury. So he was an eminent person, but this was just too much for him. So he fired Flammarion. So Flammarion was just went on to a career popularizing astronomy, popularizing science. He wrote all kinds of books, and we'll come back to him later. But again, as you can see, this idea of Mars being older has to do with the notion that because it has a thin atmosphere and because it's colder, that it's sort of evolutionarily older. That was the notion. There'd be more advanced and wiser. We'll come back to that. Okay, so here we are at Mars. Okay, this I think is Father Secchi's drawing of Mars. Okay, so what Mars then and still does attract a huge amount of attention by astronomers and amateur astronomers and the general public, and the reason is that it's really Earth-like, right? So at the time in the 18th century, all of this was known, right? That we knew that it was similar in size to the Earth, and this sort of means that it's actually about half the size of the Earth. So that's not exactly similar, but what I mean by that is it's not 10 times smaller or 10 times bigger. It's in that ballpark. And the density is smaller than that of the Earth, but it's not that different. So that's what I mean by sort of. The day is almost exactly the same as the rotation period of the Earth. The tilt of the axis with respect to its orbit around the Sun is, again, almost exactly that of the Earth, which means it has seasons just like the Earth does. It has a clear atmosphere, so unlike Venus, it has an atmosphere at all. Okay, that's important. It has polar caps. You can see this here. It has surface markings. Okay, and most importantly, these things change with time. For example, the polar caps get bigger and smaller depending on the season, so they come and go with bigger in winter and smaller in summer. So all of these things really got people thinking. Well, this is like the Earth. Okay, and all of this, as I said, was known in the 19th century. So let me just show this right at the beginning, so we have a frame of reference. So here we have a drawing of so this is the globe of Mars flattened out onto a 360 degree map here. So the right-hand side rolls over to the left-hand side there. Showing this network of lines that were called canals, and the network of lines intersects with these blobs, which were called oases by Percival Lowell, and his interpretation was that there were inhabitants of Mars that were essentially hydraulic engineers. They had to be because the planet was dying. The ground is arid. In order to irrigate the planet, they had to bring water from the polar ice caps down to the equatorial zones. So he knew perfectly well that you can't see a canal from the distance of the Earth. And so these are the interpretation that he had was that the width of the canal was the vegetation that accompanied the canal. And the round spots are oases and so forth. So I'm going to come back and say more about this, but just to, as I said, to dispel any notion here is on the same scale what the Mars Global Surveyor shows, and the thing that I key on is the dark thing on the left, sort of left of center there. That's a feature called Syrtis Major. It's the most easily recognized feature on Mars, and that's that kind of shape like the Indian subcontinent. On the left there, and you can see it corresponding to the dark place there. Okay, but more or less, there's not a whole lot of correspondence, right? So There are no canals on Mars. It's too bad. But, it's an interesting question about what they were seeing, what people were seeing. So let me sort of start that story in a different way. So if you go out at night and see the planet Mars in the sky, it has a certain size, right? There's a certain, it has a certain physical object that has a certain distance, and we would see it as having a certain size. And that size is the same as putting a penny on a stick and walking 220 yards away from it and then looking at the penny on the stick. Okay, so if you have a telescope, you'd look at the penny and you move the telescope to the planet Mars, they would look the same size. So my comparison here is that the drawings of the canals on Mars requires the ability to see detail, which would be similar to seeing the steps on the Lincoln Monument, Lincoln Memorial, or the grooves and the columns of the Lincoln Memorial, which I could only see with a magnifying glass. I tried this. I looked at a penny and I could not see those grooves without a magnifying glass. So this is an incredible thing to be able to see such fine detail. Okay, so this is an extremely difficult measurement, is the point, is to be able to see this. And so here is something that if you're not familiar with this already, you will be when you look through the telescopes tonight here. But essentially the biggest problem with seeing sharpness, seeing sharply, is the following phenomenon. So if you imagine lying down at the bottom of a swimming pool and looking up at the sun, or lying on some nice sand and looking up at the sun, what you would see is the sun wouldn't look like a nice disk, right? It would be all distorted and it would be waving around. And when any one of these patches of light went by your eye, you would see a flash. And when one of these darker places went by your eye, you would see a darkness. And this is the same thing as stars twinkling, right? That's the same phenomenon. Essentially, what's going on here is that the rough surface of the water in the swimming pool is distorting the light that's coming through the water. It's just what you'd think, and that's exactly what the Earth's atmosphere does. So the Earth's atmosphere it's not like the top of the atmosphere has waves on it. It's rather all the way through the atmosphere there are cells of air that bend the light. So it's not a perfect analogy here, but there it is. So I say a skilled visual observer, and this is the important thing. So even though the human eye has many shortcomings in terms of quantitative measurements that we'd like to have a better way to record astronomical information, it can do one thing very well, and that is it can find the instance when sometimes you'll get you'll be looking at the sun and you'll see a nice, beautiful circular disk as you're lying on the bottom of the swimming pool. Right? There will be some instances that will happen, and then everything will be clear. And so, similarly, if you're patient enough looking through a telescope at Mars, you can expect that at some point the atmosphere will be just by chance momentarily clear, when you'll be able to see all this fine detail. And the human eye and the human brain can remember that. And then you scribble, you scribble your drawing very quickly, and then you wait for the next time. You can't do that with photography. So now, of course, with modern technology, we can do fun stuff with very fast imaging and so forth. But at the time, the human eye was really where it was. That was the technical way that people observe planets. So if you Google Schiaparelli, you get a page full of evening gowns. You can ask me about that in the question and answer period. But anyway, so Giovanni Schiaparelli was an extremely eminent astronomer during the latter part of the 19th century. He was the director at the Brera Observatory. He did many things. He made this very important observation that meteor showers are associated with comets. So essentially, it was a theory of where meteors came from, in effect. But he's most famous for his very extensive observations, very careful and detailed observations of the planet Mars. And he was the person who first really championed the existence of the canals, okay, canali in Italian. And he drew maps and he named them. I think the next slide is one of his maps here. You probably can't read all of these nice names, but they're named after sort of mythical or evocative names, where deserts are named after deserts. And I mean, what do you imagine to be deserts on Mars are named after deserts on the Earth, and what do you imagine to be seas on Mars are named after, seas on the Earth. He did not interpret what the canals were. So unlike Lowell, who had this notion of that they were artificial waterways and things, he stopped short of that. But he was really an important figure, and because of his stature, people really took him seriously. And if Schiaparelli says there are lines on Mars that he chooses to call canali, then there are. So he's a very influential person. So Lowell, Percival Lowell was. Let's go back and say a little bit about who he was. He was a member of the very wealthy Bostonian family by that name. So he was independently wealthy. He really could do anything he wanted. He was was a very accomplished mathematician in terms of his academic background at Harvard. He chose instead to go to Japan and Korea and study the Oriental way of looking at life. So he published several books on the subject of the Far East. And then in about 1890, I should say this, that Mars and the Earth pass each other about once every 2 years, depending on the relative speeds of the orbits of the two planets around the Sun. But sometimes, because of the fact that Mars's orbit is relatively elliptical, they approach each other more closely than at other times. And so there are good times to study Mars, of course, when they're closest. And there was a good time in 1892 and another good time in 1894. So in about 1893, Lowell has come back from Japan and decides he's going to study Mars. The whole observatory, meaning he has to staff it with astronomers and so on. He's just created this observatory. He an interest in astronomy from some time before. He had taken a telescope with him to Japan. And so it didn't exactly come out of nowhere, but it more or less came out of nowhere. So he's dedicated himself to studying Mars, and was apparently very much influenced by one of Flammarion's books on Mars. So Flammarion was himself inspired by Schiaparelli. So the real sort of chain of influence was Schiaparelli, Flammarion, Lowell, in that order. And Lowell was the one who was an extraordinary polemicist. He was able to write a story with this logic about how it must be true that there are intelligent beings on Mars because of a logical construct. So I have one of his books that's simply called Mars. It was published in 1895, and it's an incredible read. I mean, you read the book, and you're totally convinced, that there are guys on Mars, building canals. It's amazing. And so he was a little bit on the outside because he didn't have an academic, he didn't have these academic credentials, and he was. I think the main reason he was criticized in the professional community is that he had more of the attitude that this idea has to be right, and then I'm going to collect data that will show that it's right. Okay, so that's not really the way you should do things. I mean, Galileo would never have done that, and I'm exaggerating a little bit, but that's sort of where people were. So then there were, just to dispel the idea that everybody was talking about canals on Mars, there were a few individuals, themselves of great influence, who really couldn't buy into it. And Antoniadi was one of the people who originally agreed with Schiaparelli and himself drew canals on Mars. And on the top right picture is one of Schiaparelli's drawings. And in about 1907 or something like that, Antoniadi came out publicly and said, it's wrong, right? That it's an optical illusion, that the lines are actually a phenomenon that occurs in the human eye where there are dots and you connect the dots. So it's really a psychological or physiological phenomenon. And so he was convinced that these lines actually did not exist. And this was particularly damaging to Lowell's point of view because Antoniadi himself had been one of the proponents, one of the advocates earlier on. And another doubter was E.E. Barnard, who was a very famous American astronomer who worked here at Lick Observatory until about 1895. And then he moved to my institution, Yerkes Observatory, in that year. But he was renowned as in terms of the keenness of his eyesight and his ability to see fine details. So people really paid attention to him. He accomplished many things in his astronomical career, but just focusing on Mars for the sake of this story, here's one of his drawings, which actually shows a pattern of dots, which it looks very much like what we now see as volcanoes on Mars. In other words, without actually calling them volcanoes, it looks like Barnard, this drawing is evidence, or has been called evidence, that Barnard actually discovered volcanoes on Mars. So he, as you see, there's a linear feature there, but he just never bought into this idea of lines. So he was another one, an influential doubter of the notion of canals. And then another proponent of, or opponent of canals was this fellow here, a very important individual. Alfred Russel Wallace was actually a co-discoverer of the theory of evolution, biological evolution. And he's not known to us as well as Charles Darwin, because the two of them were working kind of totally independently of each other. They knew nothing of each other's work. But Darwin had started earlier. Darwin was the older man and had started his research and his thinking and his putting together facts and observations about nature, and that allowed him to derive this concept of natural selection earlier than Wallace did. And when the two of them discovered that they were working and they found the same solution to the problem, there was a gentleman's agreement that Darwin should get the credit because he had started first. And so that was a wonderful thing, right? They were gentlemen in the best sense of the term. And so we don't know about Wallace, but he was a very important scientist in the Victorian times. And he actually contributed to many fields, including astronomy. And he wrote a very wonderful short book called Is Mars Habitable? And this is the first modern exposition of what we would call geophysics, I guess. It's essentially how a body like a rocky planet with an atmosphere responds to sunlight. And so what is the temperature of the surface of the planet for a given kind of atmosphere? And he was able to demonstrate, just on basic fundamental physical principles, that the temperature on Mars had to be well below freezing. It had to be. There's just no way that you could avoid that. So that was the first demonstration that that Mars could not be habitable because it was too cold, right? Water would be frozen. And this is one of his statements. Okay. All right, so now to science fiction. So Jules Verne, he is well known for a number of books. A French author. He was, in some sense, kind of an adventurer himself. He was quite a sailor, sailed long distances. He wrote many stories of many types, but he's known for being one of the early writers of what we now call science fiction. Around the World in 80 Days. These are some of the other stories that he wrote, just as examples, but the one that is more relevant to this talk would be his From the Earth to the Moon, which was really kind of in some ways a satirical story, a tongue-in-cheek story about a group of men in Baltimore who were during the Civil War were at sort of at loose ends, and they were essentially a gun club, and they were trying to figure out what they were going to do with themselves, and so they decided to send a missile to the moon. And so there are many adventures and so on and so forth, but this was, say, an early science fiction story in terms of sending up things to other bodies in the solar system. But 1865 was a good year for science fiction in France. So we have a couple other things. An Inhabitant of Mars was published in the same year. And then this projectile that Jules Verne had, this particular story here was regarded as the first one that talked about a controllable propelled object, a rocket that we would now call. This is well before rockets were invented. But the ideas were in the air. And going back to Verne, he was really a visionary. He really had a sense of what the future might bring. So it's really quite remarkable. And then H.G. Wells was a British author who had probably more of a scientific background than Verne did. He actually studied with Charles Huxley, who was a biologist related to Aldous Huxley, for a while, but did not eventually become a scientist. But he was active in politics. He wrote many types of. He was a very broad man in terms of the literature that he wrote. So here are some examples of his science fiction repertoire, and then the particular one that I want to focus on here is The War of the Worlds, which was published in 1897. And the top quote is from the introduction to this story. So I think you're probably all familiar with the outlines of this. It's been reprised many times in film, and there was a radio play by Orson Welles in 1938 based on the story. But it's a wonderful story. It's a very scary story, actually. It reads well even now. It's the concept of beings on a dying planet, which they are obliged to move to the Earth. The point is that this is the first story of beings on other planets that have to do with invading the Earth. Okay, so and the date is, I think, very significant. So remember, there's a close opposition of Mars to the Earth in 1894. Lowell published his popular book on Mars in 1895, and here we are in 1897 with H.G. Wells cooking up this story. And so down here, that brings us to Edgar Rice Burroughs. Okay, and he was not a scientist. He was actually, his background is kind of all over the place. He tried many different things. He wasn't a particularly literary author, unlike H.G. Wells and Jules Verne. But it's hard to argue with somebody who wrote Tarzan, in the sense that this is one of the most best-selling fictional characters in all of literature is Tarzan. Okay, so there he is, and he is responsible for the Barsoom series of science fiction stories. 1912 is the publication of the first one in this series. This is where I meant to end the story, but my title, if you probably don't remember, but the title is 1800 to 1917. That's because when I was asked to give a title for my talk, I hadn't really done my homework very carefully, and I thought that The Princess of Mars was published in 1917, and it turns out it was the Finnish translation that was published in 1917, and the actual book was 1912. So here we have it. So this is Jules Verne, H.G. Wells, Edgar Rice Burroughs were really influential to a generation of scientists. For example, Carl Sagan, and now I'm coming to the current research. Carl Sagan admitted to being very strongly influenced by Burroughs, reading these books. And so one of the consequences was that Sagan's ideas about exploration of the solar system were very influential to NASA. And so the current space program, in terms of the priorities for what probes should be doing as they visit other planets, we're still really focused on finding water on Mars and looking for life on Mars. And I really think that you can trace this sort of intellectual story all the way back from what we're doing now, and all the way back from, via Sagan, via Burroughs, all the way back. So here at the Lick Observatory, there are a number of programs that relate to finding planets going around other stars. So we like to say now that that we are the first generation that can realistically imagine that we will discover an Earth-like planet orbiting a Sun-like star in the habitable zone. In other words, at a distance between the planet and the star that would allow water to be a liquid. So we're not there yet, but we have the technology to do it. And this is a story that has really come up in the last 17 years. So it's brand new. And Lick Observatory has been one of the leaders in taking us there. So I'm getting close to the end here. So these are just a couple of references of books that I've enjoyed looking at. William Sheehan is actually by profession a physiologist, a psychologist, and so he's an amateur astronomer, very serious scholar, and he's written a number of books. But this particular one covers this same story here. From 1609 is the invention of the telescope, and 1909 was one of the last close oppositions between Mars and the Earth. And then another book that reflects on what scientists are, the history of what scientists are doing in terms of thinking about extraterrestrial life. So with this slide, I'll go ahead and ask for questions. Thank you very much. Okay.